Hi kids, today we are going to do a quick review of multiplication of a number by a 10 or 100 or 1,000. Real quick to review what we learned last week, and then we're going to move on and finish up multiplication this week with 4 by 1 digit and 2 by 2 digit multiplication. So a review of last week. If we have an area model, we're going to pretend that these are all equally sized squares. 3 times 2, or 3 on this side times 2 on that side. Essentially we have 6 total here. And when we're doing area, this is just one way to think about it. An array model is kind of the same idea. 2 things this way, 3 things this way. Together 2 times 3 is going to give me 6 total parts or pieces or whatever we're counting. Up here we have regular facts. 6 times 7 is 42. 6 times 7 tens is 42 tens, or again 420. I have 2 in the tens place, but it would take me again 42 tens to build 420. 6 times 7 hundreds is 42 hundreds. I would have 42. I would need 42 100s to build 4,200. And then 6 times 7,000. Or, to think of this another way, if we start at 0 and we have our first part at 7,000 and we've jumped, if we skip count 6 times by 7,000, essentially 14, 21, these are going to have to get smaller, 28, 35, and 42. So we would end up at 42,000 over here if we skip counted 6 times by 7,000 each. Each of these would be plus 7,000 plus 7,000. If we added up 7,000 6 times, we would end up at 42,000, or 42. I would need 42 thousands to build 42,000, and that should make sense because that's what the name says, right? 42,000. So now we're going to move on into our 4th grade standards and what we need to know before to get ready for 5th grade. So we're going to start a little small. Today we're going to be working on the area model and the partial products method. So we're going to start with an example. I'm going to try to speed up these videos, and I'm going to try to make this less than 10 minutes. Roughly. I know the last couple have been really long. I'm going to try to shorten these up. So 23 times 4. Well, if I estimate what my answer should be, it should be about 100, because I know 25 times 4 is 100. 23 is a couple less than 25. So if I do this here, I end up with 4 times 3 plus, so I multiplied the ones by the ones, plus 4 times 2 tens, or 4 times 20. And if I add these together, I get 12 plus 80, which will give me 92. 4 times 3, the partial products method would be 4 times 3 is 12. 4 times 20, or 2 tens, is 80. If I add all these up, I would end up with 92 whole things. Let's try another one. So that's a 2-digit by 1-digit problem. Let's try 314 times 8. So I'm going to rewrite this a little bit. Well, I'll just do it. 8 times 4. Put parentheses around that. So 8 times 4. 8 times 110, or 8 times 10, plus 8 times 300. And if I do all these separate problems, or the answer to a multiplication problem is called the product. So these are called partial products because I'm partially doing this entire thing but breaking it up into smaller parts. Now I'm doing it by place value. 8 times 4 is 32, plus 8 times 10 I know is 80, plus 8 times 300, well 8 times 3 is 24, 8 times 300 is 2400. If I add all those together, which I'm going to do in this way, I'm going to actually bring these over here so I can keep place of my place value. So I moved this over to there and this over to there, and now I can add it up. It's just this way I have to do it in my head. I don't want to make a mistake. I'm going to rewrite it if I feel like I need to. That's just going to be a 1, and this is 5, and this is 2. So 314 times 8 is 2,512. Again, you can do this. You don't have to do this step, but I like to stack my addition problems and subtraction just for one last check to make sure I'm adding up the ones with the ones and the tens and the tens. Okay, that's a 3 by 1 digit. 314 is 3 digits, 8 is 1 digit. Let's try another one. We're gonna 6,024 times 6. So partial products method. 6 times 4. I have 4 different multiplication problems to do. 6 times 4 is 24. And then I'm going to move down to 6 times 2 tens, or 6 times 20. That's going to give me 120. And as I write this, I'm going to try to keep my ones and tens and hundreds in the right column. 6 times 0. I'm going to put a 0 as my placeholder so I don't forget, but I know that any number times 0 is going to be 0. And then I have 6 times 6,000. And, well, 6 times 6 is 36. 6 times 6,000 is 36,000. And I'm going to fill this in oddly from right to left so I can still not start over here and get messed up over here, still keep my columns together. So if I add this up, I'm going to end up with 4 ones, 4 tens, 1 100. 36,144 is the answer to that one. So we're going to move on. A couple more examples, and that's going to be it. This is a review. We worked on this quite a bit in the school year. All of these problems, you can change the digits and numbers around, and they all work out to be, it's the same process. So we're going to try another one here. 218 times 4. We're going to do an area model and partial products method. Actually, 218 times 4. I'm going to write that over here. And I'm going to draw an area model. One important thing that we talked about during the year is this is not to scale, right? Not to scale meaning if I'm going to label the short side 4, and remember now I've got 218, so I need a 200. I'm going to break this into expanded form. The value of this 2 is 200, and then that 110 is going to be 10, and then I'll have 8 here. So I just built this number, 218, right? And so I'm going to take all 3 different smaller areas, and in the end I'll add all this up, and when I add that up, it should give me the product or the answer. So this is the area model. I'll call this partial products. That is what it's called. So I'll start with the area model. 4 times 200 is 800. 4 times 10 is 40. 4 times 8 is 32. So now if I add up all of these, I've taken 3 smaller areas, and now if I add up these numbers, that will give me the entire area of the whole shape. If I add these together, I'll get a 2, a 7, and an 8. So 872 is the answer to 218 multiplied by 4, or times 4. So we'll try it partial products way. 4 times 8 is 32. 4 times 10 is 40. Again, this is 4 times 8. This is 4 times 10. And this is going to be 4 times, what is the value of this 2? It's 200. So this will give me 800. If I add these together, I get the same answer, because whether I solve the area model or partial products, I'm going to end up with the same. It's kind of, they're very similar, and again, this is not to scale. If this length was really 4 inches, say inches as just a unit as an example, if this is really 4 inches, 218 inches would be a whole lot way that way. So again, this is not to scale. There's my 10-minute timer. This is not to scale. So just remember that's kind of different than our original example where this is a little bit closer to scale. I know these aren't perfect, but you can see here the length 3 this way times 2 that way. This is roughly to scale. This is just a model so we can explain our thinking, so we can think about what this means, but again, this is not to scale because we would run out of room pretty quickly. Let's try 1 or 2 more. 43 times 27. I'll write it over here again. Now this is 2-digit by 2-digit multiplication because I've got 2 digits here and 2 digits here. So now my area model has to look a little different. I'm still going to break it up into the expanded form, which is essentially what is the value of this 4 and this 3 and this 2 and this 7. So now I know 40 is bigger than 20. So now I'm going to break this into a 40 and a 3. And then here I need one that is 20 and a 7. And so watch what I do. I'll do this area model first. So 20 times 40. That's a little confusing maybe. Well, I know that 10 times 40 is 400. So 20 times 40 is going to be 800. And if I look here, what is 2 times 4? 2 tens times 4 tens is 8 tens. 80 tens. Because 10 times 10 is 100. 80 tens, which is 800. Again, if 10 times 40 is 400, then 20 times 40 is twice that, which is 800. Now I have 20 times 3, which is 60. Then I have 40 times 7, which is 280. And then 7 times 3, which is 21. I have to rewrite that. When I rewrite something, I usually start with the bigger numbers first because they have more digits and it's easier to add these for me together. That's going to be 1,161. So let's try it over here. 7 times 3 is 21. 7 times 40 is 280. Now this is 20 times 3, which is going to give me 60. 20 times 3 is 60. Now 20 times 40 is going to give me 800. If I add these together, I end up getting the same thing I did over here. 8 and 2 is 10 plus another one, 1,161. Okay, I think I'm going to leave it at that. I think there's an example. If you watch the video a few times maybe, there's an example for each of the problems you'll see this week. The beginning of the homework asks you to fill in some lines where there's a plus and a multiplication sign. So I'll just show you one more example so you know what you're doing. Let's take the number, I don't know, 362 times 4. So what am I going to multiply here? I'm going to multiply 4 times 2, and then I'm going to multiply 4 times 60. I'm going to add these together. 4 times 300, and then I'll do these separately, and 1,448. But on your work, this part will be blank on the first couple problems. So this is all you're going to see, and it's your responsibility to add these up. You'll see a blank line, kind of like that, and you're going to fill this in, and then later on you do it all on your own. So let me know if you have any questions, please. This is a review. Think about what you're doing and have a good week.